Hey everyone, this is Mr. Corzine. I'm going to complete the notes with you, just like I said that I would. We are working on, if I go back here to the beginning, graphing using the slope-intercept form. It's in this y equals mx plus b form right here, and the basics are that m in front of x, that's the coefficient in front of x, that's going to be your slope, and then b, the trailing term constant at the end here, that's your y-intercept. It makes things really easy when you want to take an equation and quickly make a graph. So let's skip ahead. We already did a couple of these slides here in class. Let's look at this one right here, number 3. We want to identify the slope and the y-intercept of the line with the given equation. This is super simple. This is already in slope-intercept form. So I look at the coefficient in front of x. That means the slope is 1/4. I look at the trailing constant here, and the y-intercept is a -2. It doesn't get much easier than that. For this other problem, number 4, this one's a little bit different because it's not in the form that we need it to be. Doesn't mean it can't be in that form. We just we need to rewrite it. So we're gonna solve for y basically. We did this in the last chapter, so it should work out pretty easily for us. I'm gonna take and I'm gonna add this 2x on both sides first. That'll get rid of this term over here. So I just have 3y is equal to 2x plus 9. Notice what I did there. I rearranged these two terms. We've got a positive 9, I've got a positive 2x, so I'm just putting the 2x first and then adding 9. After that, I have to get y by itself by dividing by 3. On the other side, I divide all of that by 3, so that now, once I simplify this expression, each one of these terms gets divided by 3, so I get 2/3 x plus 9 divided by 3, which is 3. So in this case, when I identify the slope, it's now in the slope-intercept form here. The slope is going to be 2/3, 2/3, and the y-intercept is 3. Here they want us to graph it. And when you look at this first problem, number 5, y equals -x, you might think, well, this is weird. This is some kind of crazy equation. Well, actually, it's not. If I put the template up here, y equals mx plus b, and I try and compare it to the equation that we have, first of all, we've got y in the right spot, equals, and then we've got our x term. And if we're trying to identify what is the coefficient in front of x, I can put that imaginary 1 in there, and I find out I've got a -1x. So my slope is a -1. And then what am I adding or subtracting? Well, it's going to be 0. If I take that and apply that information here on the graph, I've got my line crossing through, or crossing the y-axis at 0. And then the slope, the rise over the run, is going to be a -1/1. So I'll actually go down 1 and over 1. Down 1, over 1, down 1, over 1. That is my line. Describes it pretty easily. For 6, it's very much the same thing. -1/2 x plus 2. Well, my y-intercept is at a +2. And now my rise over run is -1/2. So I actually go down 1 and over 2, down 1 and over 2. I've got a few points there. I can just draw a line right through it, and now I have my line. Moving on. So tell whether the graphs of the two equations are parallel lines. We know that they will be parallel if they have the same slope. So that means I have to look and compare. In this one, my slope is 8. It's really easy to tell. For this equation right here, I have to rewrite. So I'll change colors here real fast. I'll subtract 8x on both sides. And now I have y is equal to a negative 8x plus 3. It's in slope-intercept form now. That means my slope is a negative 8. And so is it parallel? Nope, it's not parallel. The slopes are different from each other. For number 8, 2x plus 4y equals 5. Well, again, I have to rewrite a little bit. I'm going to subtract 2x on both sides. I don't know why I put it there. This should be over here. Let me just rewrite that one again. Okay. Subtract 2x. So now I have 4y equals a negative 2x 5. I now have to divide by 4. So y equals, it's a negative 2 over 4, so a negative 1/2 x plus 5. Okay, the y-intercept doesn't matter so much. Over here, I've got a negative 1/2. It looks a little different because it's in decimal form. The y-intercept doesn't really matter. So are these two slopes the same? Yes. So they are parallel. Finally, for my last one, y equals 3x plus 4. I'm going to rearrange this. So I'm going to add 3x on both sides. This cancels out. I get y equals 3x 7. I look at my slopes. This slope is 3. This slope is 3. So yes, this last one, they are parallel. Finally, let's move on to our last problem. It's really exciting. It's about toilets, so that's cool. Yeah, really, really fun. Let's see if I can draw a toilet. I don't know if I can. I'll just do got the handle here, got the bowl, got the little thing in the back. Yeah, that'll do, right? Big toilet seat. All right. Anyway, back to the math. It says that a new toilet model has 2 different flush settings in order to conserve water. You've seen that before. They got the little button and the big button. One setting uses 1.6 gallons of water per flush. The other uses 0.8 gallons of water per flush. The total amount, W, in gallons of water used in the first setting is given in the equation W equals 1.6 F. F is the number of times the toilet is flushed. Total amount of water used in the second setting is given here. W equals 0.8 F. Okay, it's half of that. Graph both equations in the same coordinate plane. What do the slopes and the w-intercepts mean in this situation? Okay, well, I'm going to treat this W equals 1.6 F like it's in slope-intercept form. Above there, I'm going to write y equals mx plus b. You notice F, number of flushes, is on the x-axis. The water use, W, is on the y-axis. So this can be my water can be my y, and then the flushes can be my x. Well, this does not have a y-intercept, so guess what? It's going to be plus 0. That means it's going to start here, and it's going to go up 1.6 every time. Up 1.6 over 1. Up 1.6 over 1. If I go up 5 times, that means 5 times 1.6, that's going to be about 8. And then I'll go over 5, so that puts me right about here. And there's my graph. For my other equation, W equals 0.8 F. Again, this is the same as y equals mx plus b. So I've got my slope 0.8, and then I'm also adding 0. So it also will start at 0. And then it goes up 0.8 over 1. Up 0.8 over 1. That means, let's see, if I multiply it times 5, 0.8 times 5, that'll get me up to 4. and then I go over 5 just like before, and this line goes like this. Now that I graph them, I've connected the flushes and the gallons to what it means in the situation. It's on the X and the Y axis. I'll move these things down now. And oops, move that up. Nope, I don't want to do that. I want to do this. Okay. How much more water is used by the first setting if the toilet is flushed 10 times? All right, well, this is where we just plug in 10 flushes. 0.8 times 10 gives us the amount of water in gallons. So that's going to be 8 gallons. And then on the other side, I'm going to do 1.6 times 10. That gives me the amount of water. So that's going to be 16 gallons and 10 flushes. So 16 minus 8, it gives us 8 more gallons are used. Okay, seems simple. It's not necessarily something where you have to graph it to get this answer, but you can see how all the information comes together, and you can relate it to y equals mx plus b, and it might be a little quicker and easier for you to solve the problem. Okay, that's it for our notes. You guys are going to finish the equation or the problems on the worksheet. That was worksheet 4.5, just the front, numbers 1 through, I believe that was 18. So, okay. Have a good one, guys. We'll see you tomorrow.